All right, so let's talk about ions. So ions are basically atoms that contain a charge. Okay, so let's talk about the atomic structure. Okay, so we know that atoms consist of three parts. They have protons, they have electrons, and they have neutrons. Okay, so protons, it's kind of like your positive piece. They bring in the positive charge of the atom. Okay, electrons, they bring in the negative part of the charge of the atom. Okay, and neutrons are just simply neutral. All right, there's no charge that's associated with neutrons. And then within the atom, we know that you have the protons. So these are my protons. They're in the nucleus, all right? The neutrons are with them. You know, their job is to stabilize the nucleus. And then around the nucleus, all right, in the electron cloud, you have our electrons that's kind of just zipping by. So here's kind of our little depiction of the atom, okay? Now, when it comes to atoms, okay, all right, anytime we typically use that term, all we're really saying is that the number of protons, okay, actually equals the number of electrons, okay? So this makes the atom have a neutral charge overall, all right? So if you have, like, for example, carbon has 6 protons. If it's a carbon atom, all right, then it will also have 6 electrons. In this case, that carbon atom overall has a neutral charge. But this is not necessarily true with ions. So with ions, okay, the number of protons actually do not equal the number of electrons, okay? And so now at this point, ions, they have a specific charge that goes along with them. Okay, so they could either be positively charged, and if they are positively charged, that means the number of protons is greater. I'm gonna actually draw this in white. Is actually greater than the number of electrons. All right, and so this just associate with a positively charged ion, charged ion. Okay. In this case, we call a positively charged ion, the term that we tend to give it is called cations. All right, the way I kind of remember this is that the T is kind of like a plus sign, a positive sign, a positive sign ion, cation. All right, so anytime you have more protons than you have electrons, the ion is positive, and thus it is a cation. Okay, while if the number of protons is less than the number of electrons, or in this case, the number of electrons is greater than the number of protons, all right, then you have a negatively charged ion. All right, and when that's the case, we call this anion. Okay, so anytime you hear the term an anion is basically a negatively charged ion. The way I could remember this is you have anion. Well, actually, let me kind of rewrite that. Oh, that's not the eraser. Okay, so anion is a negative ion. Okay, a negative ion, an anion. I guess that kind of works out, okay? So let's see how that kind of looks like. So, kind of getting a new section here. Let's talk about oxygen, okay? So here is a nuclear symbol of oxygen. So here we got the mass number, the atomic number. So hopefully when you look at this, you quickly see that your number of protons is 8, your number of electrons, because this is neutral, there's no charge here, this is 8, and the number of neutrons is 8 as well. So if you were to draw this out, draw what we call a Bohr's model of this atom here, and then we'll talk more about Bohr's model later. So here are your protons in red. So you have 1, 2, 3, 4, 5, 6, 7, 8. Then you have 8 neutrons. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And around the neutrons, you have your electrons. Okay. So in this case, you have, so your first energy level, you have 2 electrons. And then your second one, we're going to draw 6 more. So 2, so this is 4, 6. All right. So all together, and then you have 8. I'm sorry. So all together, you have 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. Then you also have your 8 neutrons and 8 protons. So this is an atom of oxygen. All right. Now, then just show the difference between an atom of oxygen and an ion of oxygen. So here's an example of an ion of oxygen. So here we still got 8 protons, because remember, what identifies an atom is the number of protons. And each element has a different unique number of protons. So you change the number of protons, you have changed the element altogether. So oxygen always have 8 protons. In this case, all right, when we're looking at this, here's our charge. The charge is -2. What is it telling us? So this -2, so what we got to pay attention here is this negative sign. This negative sign is not a minus, or it's not a subtraction sign. It's a sign that relates to charge, all right? So it's telling us that this atom or this ion has a negative charge, okay? Now, when you're trying to compare the number of protons to the number of electrons, what this number is telling you is that because it's negatively charged, you have more electrons. So in this case, you got more electrons than you have the number of protons. By how many? 2. So there's 2 more electrons than there are protons. So if we go with this idea, right, and we see, okay, well, since I have 8 protons and I got 2 more electrons than I have protons, then that means I have 10 electrons, okay? And then neutrons, in this case, doesn't change since our mass number is 16. We know that the mass number is the sum of the protons and neutrons. So if that's the case, if protons is 8, the only way that this mass number could be 16 is if also you have 8 neutrons. So how does this look like? Well, once again, you have your 8 protons, so 1, 2, 3, 4, 5, 6, 7, 8. You also have your 8 neutrons, 3, 4, 5, 6, 7, 8. So this symbolizes my nucleus. Now I'm going to draw out my electrons. So here we have a first energy level. You have 2 electrons here. Then I'm going to draw my second energy level, and I'm going to draw the rest. So 3, 4, 5, 6, 7, 8, 9, 10. So now let's compare the two. All right, so let's compare these two illustrations of oxygen. All right, so when you're kind of looking at this, once again, we have the same number of protons and neutrons here, but the number of electrons is what makes things different. All right, and so that's why this is considered to be an atom, so because you have the same number of protons and electrons here. But in this case, the one on the right, this is considered to be an ion because the number of protons differs from the number of electrons. All right, and so that's just kind of the big thing about ions. Ions are just simply charged atoms.